Good afternoon, students. We have finished Unit 3. Now you have two more units. Unit 4 is Group Theory. Unit 5 is Spectroscopy 1. I'll go to Unit 5, then we will come back to Unit 4. Okay. So, Unit 5 is Spectroscopy 1. Spectroscopy, if you take, it is a very important topic in chemistry. If you go for any higher studies, let it be MSc or MPhil, or you go for some interdisciplinary studies like nanomaterials, nanotechnology, or biochemistry, all the fields it needs spectroscopy. If you are going for research, the basics of all the subject is spectroscopy, because if this is technique which tells us what is matter or what is the structure of matter. If you are finding out a substance, you have to find out what is the structure. You are preparing, for example, you are doing some organic synthesis, you have synthesized a new material. Then if you want to say what is that substance, you have to use certain techniques, analytical techniques. For that, one of the main techniques used is spectroscopy. Spectroscopy involves different types, that is UV visible is there, IR is there, spectroscopy is there, NMR spectroscopy is there, EPR spectroscopy is there, mass spectroscopy is there, Raman spectroscopy is there, fluorescence spectroscopy is there, Mohs bar is there. Like that, there are different types, but that is the basis of analysis of any compound. Okay, so this is a very important topic, and it's a very beautiful topic if you understand it. That is what I says. If you understand it, it's a very beautiful topic. These are the basics only you are going to learn. So if you understand and keep in mind the basics, it will be very useful for you in your higher studies. Okay, you have just an introduction only. So in the spectroscopy one, you will be introduced to some spectroscopic technique, and in the next semester spectroscopy 2 you will be studying. They will be seeing some other spectroscopic technique. So the topics are introduction, what is spectroscopy, then various types of molecular spectra, electronic spectra. There you have to study vibrational and rotational energy levels, Born Oppenheimer approximation. Okay. Then rotational spectra of diatomic molecule, another set of spectroscopy. There you have to see calculation of bond length, moment of inertia from the rotational spectra. See, bond length you can calculate from rotational spectra. Then selection rules, effect of isotopic substitution, then some numerical problems. Next you will study UV visible spectroscopy theory, types of transitions, selection rules, factors affecting absorption maxima and intensity, then application. Next, IR spectroscopy. What is IR spectroscopy? What is its theory? Then under the theory it comes stretching and bending vibrations, factors influencing vibration frequency, important spectral regions for the characterization of functional group, fingerprint region, determination of force constant, qualitative relation of force constant to bond energy, selection rules, modes of vibration in polyatomic molecule, vibrational modes of water and ammonia, application and numerical problems. IR spectroscopy deals with the vibrational energy level. So when we are passing the light through some material, what happens to the vibrational energy levels? So whether it bends or stretch, that type of vibrations, then how in a polyatomic molecule it bends, stretch, etc. You will be seeing. Okay, it looks, the words looks like tough one, but it's all very simple concepts only. Understand and go ahead. Okay, now we'll come to the introduction part. Spectroscopy. You imagine when you are in a room where there is very dim light, someone is coming and lighting a lamp or a torch to your face, means what happens? You will react or you will respond. Is it a something you will say, and you will close your eyes fastly. So when a light is interacting with you, you feel some disturbance and you will be responding to that. That is only spectroscopy. That is, it is the study of interaction of electromagnetic radiation with matter. That matter what we take here can be a molecule or an atom or an ion. The simple one. If you are sitting in the room when somebody is lighting a lamp to your face, torch to your face, how you respond? அதே மாதிரி ஒரு ஆட்டத்தில் when we give the light அது வந்து ரெஸ்பாண்ட் பண்ணும். அந்த ரெஸ்பான்ஸ் எப்படி we can know? அந்த எனர்ஜி லெவல்ஸில் அந்த டிஸ்டர்பன்ஸ் வரும். that disturbance வந்து நம்மளை will collect it, and from the disturbance we will able to understand the nature of the matter. That is what is spectroscopy. See, sunlight in it, you can see here EMR. Sunlight is a example for spectroscopy. Okay, sorry, light. Okay, so light, when it comes, what happens? Certain materials will absorb. For example, photosynthesis will happens. How it will be absorbing the radiation. The chlorophyll or the plant will absorb the radiation. It will make carbon dioxide and water to react in presence of the light, or the energy from the light it will be taking, and it will make use of that energy for doing the reaction. Sometimes what happened, if a dust particle is there, it gets scattered. Scattered means it will go in different directions. Okay, in the cloud or in the atmosphere, when dust particles is there, then sometimes it will transmit, that is, it enter and go. So these types of different types of processes will be taking place: scattering, absorption, transference, etc. And from these processes we can identify, if you find out what is the nature or how the matter has behaved to these processes, we can get an idea of its nature. That is what is spectroscopy. So spectroscopy is the study of interaction of electromagnetic radiation with matter. Matter can be atom or molecules or ions. Then the instrument which used or which help us to measure these interactions we call by the name spectrometer or spectrophotometer. Then what we get as an result, we call it a spectrum. So normally spectrum will be a graph obtained by plotting either absorbance or transmittance of radiation as a function of wavelength, frequency or wave number. Frequency, wave number, that will be in the one axis, and absorbance or transmittance in the other axis. Appadi vandu we get a graph. From the graph we will able to explain what type of interaction it has made with the matter. That is what is spectrum. Okay, it's a plot, or it is the result which tells us what is the interactions happened. Now, before going to the spectroscopy, different spectroscopy, we should have a idea of what is radiation, what is light, etc. Okay, James Maxwell, he was a scientist in 1864, proposed that a change in the electric field could create a magnetic field, and change in magnetic field could create an electric field. Till that time, electric fields and magnetic fields were known. So what he told is, if you have an electric field, if you change it, it can produce a magnetic field. Similarly, if you have a magnetic field, if you make some changes in it, it can result in production of electric field. The changing magnetic and electric field travel through a space as transverse waves. Waves ആയിട്ട് അത് സ്പേസിലൂടെ ട്രാവൽ പണം. These waves are called electromagnetic radiation. They are known as electromagnetic radiation, and they travel with a constant velocity. So the white light or visible light is an electromagnetic radiation. So spectroscopy is interaction of electromagnetic radiation with matter. What is electromagnetic radiation is when a atom or molecule hits something, there can be some form of waves. So if an electric field is generated, that electric field can generate a magnetic field, and also magnetic field can generate an electric field. So they both the components will be there, and they travel as a wave. So that wave is what we call it as electromagnetic radiation. So electromagnetic radiation is a form of energy traveling with a constant velocity. Or constant velocity, that is speed. Speed per second is velocity. ഒരു സെക്കൻഡിൽ എவ்வளോ ഡിസ്റ്റൻസ് മൂവ് ആകും, that will be constant. So that type of energy we call it as electromagnetic radiation. Electromagnetic radiation is a form of energy traveling with a constant velocity. അതിൽ white light is an example of electromagnetic radiation. உங்களுக்கு தெரியும் white light velocity 3 into 10 to the power 8 meter per second. So എല്ലാ electromagnetic radiation travel with the same velocity 3 into 10 to the power 8 meter per second. In characteristics of electromagnetic radiation, it's a form of energy traveling with a constant velocity. They show dual character or dual nature. That is, they have both wave motion and particle nature. They travel in the form of wave. That is wave nature. If it is hitting something, it can undergo the reflection. That sort of properties we call it as particle nature. Scattering what means? It's just like bouncing. You are throwing a ball at something, it comes back. So ball is a particle. Adhe madri light, when you are making to interact with some material, it comes back. That is what is reflection or scattering. Reflection in one direction, scattering means in all directions. So that shows that it has particle nature. Then electromagnetic waves are associated with oscillating electric and magnetic field perpendicular to each other and also to the direction of the propagation. See, electromagnetic radiation, if this is the one you take, there are three lines, is it? One is x-axis, one is y-axis, and one is z-axis. If you take this z-axis as the propagation, the direction z-axis direction as propagate ayala, it has a magnetic field opposite to that. Okay, so this is perpendicular to it. In adhe madri, it has an electric field perpendicular to this and this. That is, if this is y-axis, x-axis is remaining. So that will be through x-axis. See, this diagram clears you. So this is x is the, okay, here it is propagation is given as x-axis. So magnetic field, if you take the red color, it goes in the y-axis. Then electric field, if you take in the z-axis, the blue line, see, all the three are perpendicular to each other. So electromagnetic radiation, it got from that it has both magnetic field and electric field. What it means? The electromagnetic radiation, a magnet, if you keep in a magnet, it will deflect the magnet. Or electric current you keep means it can deflect the electric current. That is, it has both the characters. Okay. These waves do not need a medium for movement. Adukku medium it is not needed. Vacuumthilude it will be traveling. They are characterized by their frequency, wavelength, wave number. Certain terms is there, we'll see later. So they are characterized or defined by frequency, wavelength, and wave number. If you want to say this is an electromagnetic radiation, we used to say, but it has a frequency of so and so. For example, white light means 380 nanometer to 760 nanometer. That is the wavelength. So that part we call it as visible region. Then energy of radiation is directly proportional to frequency. Radiation energy it is directly proportional to frequency. Then emission or absorption of radiation is quantized. So when you are supplying a light to a substance, this substance can absorb certain energy or it can emit the radiation. So this emission and absorption will be only in quantized, that is in small packets. That packets is known as photon, and it can be calculated, or energy, this is equal to h into nu, where h is Planck constant and nu is the frequency of the radiation. So visible light or 800 nanometer light ஒரு மேட்டரிலோட பாஸ் பண்ணும்போது அதை எனர்ஜி அப்சர்வ் பண்ணியால அந்த லைட்டிൻ്റെ எனர்ஜின்னு சொல்லுന്നത് h into wave numberna you have to convert into frequency. அது frequency convert பண்ணிட்டு ஆ term multiply பண்ணினா தான் it is the energy. Then electromagnetic radiation can also split into various. Electromagnetic radiation divided into various radiation based on this frequency of wavelength. Or a set of wavelength we call it by one name. For example, visible light. In UV, ultraviolet radiation, another set of radiation. Infrared radiation, that is another set. That classifications we make based on the wavelength or frequency. That is what it is characterized by frequency or wavelength or wave number. So your light one, if you are passing through something, for example or prism, prismത്തിലൂടെ pass பண்ணும்போது white light we can see the 7 colors. So the 7 colors one, it is a splitting of the white color. That process dispersion. அதே மாதிரி electromagnetic ரேட்டிங்கிலூടെ பாஸ் பண்ணும்போது different wavelength உள்ள radiation ஆகிட்டு we will able to convert it. That process we call it as dispersion. See, the electromagnetic ray split into various components. This process is called dispersion. White light splitting into 7 colors is an example of dispersion. ഒരു പ്രിസത്തിലൂടെ വൈറ്റ് ലൈറ്റിനെ പാസ് പണിയാൽ it will convert or it will divide into violet, indigo, blue, green, yellow, orange and red. That is what we call it as VIBGYOR. So it can be, that is example of dispersion. This is the electromagnetic radiation, we can do it. In units, we will explain frequency, wavelength, etc. So when we are doing that, you have to consider the electromagnetic radiation as a sinusoidal wave. Sinusoidal wave means this is the example. Okay, if you can represent this this in the inge start panni ipdi you can, this is sinusoid. If you are doing it in this way, the inge start panni ipdi you can represent this it ipdi represent by the cosine. This is sinusoidal wave. Okay, so idu madri you have to imagine. Okay, so this is the sinusoidal wave. In a first one, wavelength. Wavelength is the distance between two adjacent crust or trough in a particular wave. ഒരു വേവ് എടുത്താൽ ഇതൊക്കെ വന്ന് മാക്സിമം ഇருக்கு മിനിമം ഇருக்கு. So maximum we call it as crest, CREST. The minimum we call it as trough. So ഒരു distance between in the trough in the middle point in the this is crust the mid point എടുത്ത് ഈ length measure பண்ணிയാൽ that is what is known as wavelength. അതേ മാതിരി trough minimum എടുത്താൽ ഇതിൻ്റെ മിഡ് പോയിൻ്റ് ഇതിൻ്റെ പീക്കിൻ്റെ മിഡ് പോയിൻ്റ് എടുത്ത് ഒരു ക്രസ്റ്റിന്ന് ഒരു ട്രഫിന്ന് അനദർ ട്രഫ് വരെയുള്ള ഡിസ്റ്റൻസ് ഇഫ് യു കാൽക്കുലേറ്റ് ദാറ്റ് ഈസ് വാട്ട് ഈസ് നോൺ as wavelength. ഇത് വന്ന് ലാംഡ വെച്ച് വി യൂസ് ടു ഡിനോട്ട് ലാംഡ. Then ഇത് വന്ന് ഇതിൻ്റെ യൂണിറ്റ് വന്ന് ലെങ്ത് ഉള്ളിട്ട്. സോ യു ക്യാൻ യൂസ് എനി ഓഫ് ദി length unit angstrom because it will be very small. That is why we go for angstrom or nanometer or millimeter, centimeter, meter. And 1 angstrom is equal to 10 to the power 10 meter only. So the distance will be very low. It will not be in meters and 1 nanometer is equal to 10 to the power minus 9 meter. 1 millimeter is equal to 1000 meter and 1 centimeter is equal to 100 meter. So in very low values only we will get. So we can represent it either by angstrom or nanometer. These are the two things normally we use to represent. Then visible light constitute waves ranging from 380 nanometer to 760 nanometer. 380 nanometer in the 760 nanometer വരെയുള്ള radiation we call it as visible light. That is the white light what we see. That is only the one which is sensitive to the eyes. UV, IR we will not able to differentiate. We are not able to see. Only what we can see with our naked eyes is this one. That is why sun radiation, sunlight will produce UV in the cell, but we are not able to see UV. We have to protect our skin from UV radiation. UV radiation, if you are not able to see, we will not be able to see by our eyes, but we says that it is present in the sunlight. Then frequency, it is the number of waves passing through a point in 1 second. Okay, a point if you take, the wave is passing like this is it. 1 second time eduthaal how many waves will pass through this point. That is what is known as frequency. Okay. It is expressed by the term nu and cycles per second. ഒരു സൈക്കിൾ എന്ന് சொல்லுனா இந்த இங்கேருந்து வந்து இங்கே வரைக்கும் உள்ளது தான் this is one cycle. So எவ்வளவு cycles ஒரு செகண்டில் பாஸ் ஆயிருக்கோ that is what, and that we used to say by hertz. HERTZ, HZ we used to represent, and it is 1 cycle per second is equal to 1 hertz. In frequency, this is what is the one. Frequency, if you take, you can say that it is inversely proportional to wavelength, and that when you take the proportionality constant, it will become velocity of the light constant. So velocity of the light divided by wavelength, or nu is equal to c by lambda, where c is equal to velocity, which is equal to 3 into 10 to the power 8 meter per second. So if you take this, you can see it is inversely proportional. So see this curve, high frequency means the wavelength will be small. Low frequency means wavelength will be large. Okay, so they are inversely proportional. This curve is the distance between two crust is what is wavelength. ഒരു സെക്കൻഡിൽ പാസ് பண்ணுது. അപ്പം if you have low wavelength എങ്കിൽ നിറയെ വേവ്സ് ഒരു സെക്കൻഡിൽ ഒരു പോയിന്റിലൂടെ പാസ് ആകും. Long wave എങ്കിൽ the number of waves passing will be less. So frequency വന്ന് inversely proportional. High frequency means short wavelength. Low frequency means slow wavelength. Another term is wave number. Wave number is reciprocal of wavelength, and it is total number of waves passing through the space of 1 centimeter. ഒരു സെൻറ്റിമീറ്റർ ഡിസ്റ്റൻസ് വി ടേക്ക് ഒരു സെക്കൻഡിൽ എவ்வளோ വേവ്സ് പാസ് ആയിരിക്കോ ദാറ്റ് ഈസ് വാട്ട് ഈസ് വി കോൾ ഇറ്റ് ആസ് വേവ് നമ്പർ. ഓക്കെ, ആൻഡ് ഇറ്റ് ഈസ് ആക്ച്വലി റെസിപ്രോക്കൽ ഓഫ് വേവ് ലെങ്ത്. സോ ദിസ് ഇസ് വി യൂസ് ടു ഡിനോട്ട് ബൈ nu bar. So nu bar is equal to 1 by lambda. Okay, nu bar is equal to 1 by lambda. Then so it is lambda we have units in angstrom, nanometer, centimeter, etc. Normally we used to denote it by centimeter inverse. Then next one is energy. Energy of a wave is related to its wavelength, frequency and wave number, and we can calculate using this expression, that is E is equal to, what should come to your mind is h nu. Okay, that is Planck's constant and frequency. Then nu is related to lambda by c by lambda, so you can write this is equal to h into c by lambda. Then 1 by lambda, you know it is equal to nu bar, so what you can write, E is equal to h nu bar. So E is equal to h nu bar, or E is equal to h nu, or E is equal to h c by lambda. Okay, so that is the relationship between frequency, wavelength and wave number. Planck's constant, it is 6.626 into 10 to the power minus 34 joules second. C is velocity of the light, nu is frequency, lambda is the wavelength, and nu bar is the wave number. Now electromagnetic spectra. I told the electromagnetic radiation can be split into or can be divided into various radiation based on the wavelength or frequency. Arrangement of this radiation either in the increasing order of the wavelength, if increasing order of the wavelength means the frequency will be decreasing, or in the decreasing order of wavelength, frequency increasing. That arrangement is what is known as electromagnetic spectrum. And if you take, you can see here waves, radio waves, TV waves, radar wave, microwave, infrared, visible light, ultraviolet, X-rays, gamma. These all are electromagnetic radiation only. Lambda, if you take radio waves in the 10 to the power 2 meter. TV waves in a 1 meter, radar 0.1 meter, other range than. Okay, microwaves 10 to the power minus 2 meter. It is not so much specific, we can't divide. ഇപ്പോൾ നമ്മളുടെ വീട്ടിലുള്ള ബൗണ്ടറി മാതിരി, the boundary between two neighbors, we can do it by a compound wall exactly. But electromagnetic radiation എടുക്കുമ്പോൾ you can't divide in specific way, it may be overlapping, so we take a range only. Okay, so visible light 10 to the power minus 7 meter, like that. If you take in this way, it is decreasing order of lambda. Then you take frequency is increasing 1 megahertz, 1000 megahertz, 100 megahertz, 1000 megahertz, 10 to the power 10 hertz. அது மாதிரி it is increasing in this order. So frequency வந்து directly proportional to energy. So energy will increase in this order. The wavelength will be decreasing in this order. Okay, இதில் வந்து when it is big microwave ultraviolet infrared and ultraviolet in between ஒரு இது இருக்கு, that is what is visible, right? And again can be split into VIBGYO. This is what it is shown. Okay, so that is the arrangement is electromagnetic spectra. If you take all these radiations, they travel with the same velocity, but their properties will be different. Okay, for example, X-ray can pass through glass and muscles, but white light cannot pass through muscle, or glass it can pass, but muscle it can't pass. Then radio waves can pass easily through the air load it can pass fastly. That is why we make use of radio waves only for transmission of radio, television and all. Television one, it will be telecast in one place and it will come to our home, that we passes through the radio waves. Then UV visible IR radiation can bend by reflection. Cosmic rays, if you take compared to all the things, this has the highest energy. So because of this different property, we can make use of this property for various purpose. For example, if you take the case of radio waves, that is what we used to use it for radio, TV, television akapakan. What we use is radio waves. In infrared eduthalu, what you can see is that when you have some pain and all, when you go to the hospital, they will be sending you one radiation, that is infrared radiation. Visible is the one make us see all the object. Microwave one, ultraviolet one, we have to sunlight la irukku. So if